In this video, we are going to talk about the slope-intercept form of the equation of a line. As a recap, slope is a measure of steepness. A positive value means your line is increasing, and a negative value means your line is decreasing. Also, as a recap, the y-intercept is the point where the line crosses the y-axis and has the coordinates 0 and some number value for y. So when we talk about the slope-intercept form of the equation, it will contain the slope and the y-intercept. The slope-intercept form of the equation of a line is y equals mx plus b, where m is the slope, b is the y-intercept, and x, y is a coordinate pair on the line. For example, if we look at y equals 1/3 x plus 4, we can identify the y-intercept because it's here in the form y equals mx plus b. We know that the b value will be the y-intercept. So the coordinates of the y-intercept would be 0, 4. M represents the slope, and m is the coefficient of x. So it doesn't matter what order y equals mx plus b comes in, m is the number that is attached to the x. So in this case, it's 1/3. You don't include the x when you're writing the slope, it's just the value. In this second example, the y-intercept would be 0, 7, and the slope is -2. In our third example, the y-intercept is -3, and the slope is -2/3. So take a second and try it for yourself. List the y-intercept and the slope of the linear equation y equals -1/2 x minus 2. Hopefully you came up with the slope as -1/2 and the y-intercept as 0, -2. When we talk about lines, sometimes we need to describe parallel and perpendicular lines. So parallel lines never intersect, and they have the same slope. Perpendicular lines intersect at 90 degrees, and they have opposite reciprocal slopes. That means that a line and its perpendicular will have slopes that are opposite signs. One will be positive, one will be negative, and the coefficients of x will be the reciprocal of each other. For example, if we had a slope of a line equal to 2/3, the perpendicular slope, which has this little upside down T symbol, would be negative because our first slope was positive. And instead of being 2/3, we flip our fraction and make it 3/2. So this is a 2/3 is the starting slope, and the perpendicular slope is -3/2. Given that information, what is the slope of a line parallel to 2x minus 3? Remember that the coefficient contains the slope. This is the slope of our original line. So the slope of our parallel line, that looks like two L's beside each other, would be the same. So the slope would be equal to 2. Next example, what is the slope of the line perpendicular to y equals 2x minus 3? Well, our perpendicular slope, m with a little upside down t, would be negative because we need an opposite sign, and then it would be reciprocal. Currently, this is a whole number, and recall you can write it as 2 over 1. So the reciprocal would flip it and make it 1 over 2. If your slope is already negative to start with, then the opposite would make it positive. If we have a slope-intercept form of a line and we want to be able to graph, there are 3 steps. The first thing you need to do is plot the y-intercept. Recall that a y-intercept will occur on the y-axis. Then, from that point, so from the y-intercept, you're going to count the slope both forward and backward till you get a couple more points, and then you will connect the dots. Hopefully you'll use a straight edge. So for example, if we look at the first one, our y-intercept is -1. So we know that our y-intercept has the coordinates 0, -1, and we plot a point there. Then we look at the slope. The slope is the coefficient in front of the x. In this case, there's nothing written there. That means there's an invisible 1. So our slope is equal to 1. Recall that slope is the rise over run. So if we write this as a fraction, it would be 1 over 1. And now we know that's the rise, that's the run. So from our point that we graphed, we will count up 1 and +1 to come to our next point. And then we can do it again, up 1, +1 to come to our next point. If we didn't have space, if we go back to our y-intercept, we could count backwards by going down 1, left 1, so both negative. And notice we still get a point that will exist on that line, and we would hopefully use a straight edge to draw our line that exists pretty much through the whole coordinate plane. For our second example, our y-intercept is at -4. So we know our y-intercept is at the coordinates 0, -4, and we can go ahead and plot that point. Our slope this time is equal to 7. Recall that this is a fraction rise over run, so it's 7 over 1. That means we're going to go up 7, and we're going to go right 1. So from the point that we started with, we would count up 7. So 1, 2, 3, 4, 5, 6, 7, and then +1 space. So we end up having a second dot there. We don't have enough space to put 2 points on our 3 points on our curve. So we'll just have to make do with those 2 and connect them with a straight line. Third example, our y-intercept exists at -2. So that has the coordinates 0, -2. So we put a dot there. And then our slope is equal to -1/2. In this case, we assign that negative either to the top or the bottom, but not both. So this means -1 over 2, or it means 1 over -2. So from the point that we graphed from our y-intercept, we can go down 1 and positive 2 to find our next spot here. Or from that y-intercept, we could go up 1 and left 2 to find our next spot here. Once we have our spots, we can graph it. Oh, that was terrible. Recall, a negative slope is a decreasing line and a positive slope is an increasing line. So you can give yourself a little mental check. If you look at number 1, the value in front of the x, or the slope, was positive, therefore our line is increasing. On number 2, our slope is positive, therefore our line is increasing. On number 3, our slope is negative, therefore our line is decreasing. Lastly, sometimes you don't have an equation in slope-intercept form and you need to rearrange it. So we start by isolating the y term so that we can get it into the form of y equals mx plus b. In this form, the x term is on an opposite side of the y, and the y is isolated so that it only has a coefficient of 1. So in this example, I start by subtracting 2x to both sides. So I have 6y equals negative 2x plus 18. Notice that I put the negative 2x in front of the 18. That's so that it ends up looking like the form y equals mx plus b. Secondly, the coefficient of y is 6. So I have to isolate y further by dividing by 6 on both sides. Recall, everything has to be divided by 6. So y is going to be alone now. Here, we can simplify this fraction into negative 1 over 3x, or negative 1/3 x, that's fine. And then we still have to divide this term by 6, and we get positive 3. We just changed the equation that we were given, the two-variable equation, into slope-intercept form. Note that the y-intercept in this case has the coordinates 0, 3, and the slope in this case is negative 1/3. All right, take a second, pause the video here, and try it with this next equation. All right, hopefully you got y equals negative 1/5 x minus 3. If you go up to our work, you can see I added x to both sides, which left me with negative 5y equals x plus 15. I then divided by negative 5 on both sides, and I divided each term by negative 5. So we get y equals negative 1/5 minus 3. Now you can practice.